Let's talk about how we can find the zeros of a function. And I'm just going to talk about a few of the basic techniques. There are quite a few techniques, but we're just going to go over some of the basics and some of the ones that I like to use. Here are the basic steps for finding the zeros. The first thing you want to do is take the f of x that you see in your function equation and replace it with 0. And the reason we do that is because, if you recall, the zeros are just the values of x for which the function will equal 0. It is the place on the graph where you will go through the x-axis without any movement on the y-axis. So they are essentially your x-intercepts. Then you will solve the remaining equation for the unknown. It's the solving of the equation that most students get hung up on. How do we get through that equation to find those values of x? When you're solving for the unknown, you have several techniques that you can use. And these aren't necessarily all of them. But you can use factoring. You can use basic equation solving techniques, and that would depend on what type of equation that you're looking at. You can also use the quadratic formula, which I like the quadratic formula, even though it takes a little longer than factoring. Sometimes students get hung up on the whole factoring process, but the quadratic formula is straightforward, and factoring isn't always a viable option. So the quadratic formula is always a viable option, so I always like to just keep that in my bag of tricks. If you can't quite remember how to use the quadratic formula and you want to review it, I placed review materials in the extra resources link, so you might want to go through that. But I am going to use the quadratic formula on the first example that we do here in this video. So you might want to just watch some extra resources if the review that I do here is not enough. The last technique that we're going to talk about is by graphing. I think graphing is a great technique. You can use an online graphing tool, you can use your calculator, but even though you may be told to find the zeros algebraically, I always recommend using the graphing method as your backup to check your answers, because it's quick and it's easy. If you're using a graphing utility, you could just plug your equation in and check your answers to make sure that you're correct. And I'm going to show you how to do that as well. So let's take a look at this first example. This is example 1 in your text in section 1.5. And they solve this one through factoring, and they use reverse FOIL, and they just find the two factors that would equal this trinomial. But I'm going to use the quadratic formula for this one. Notice that the quadratic formula is set up to give us two results. It is set up with the plus or minus, and that means that it's going to give us a result by adding what we get to this negative b and subtracting what we get from this negative b. The first thing we need to do in our equation before we use the quadratic formula is to identify what our values of a, b, and c are, because those are the values that we use in the quadratic formula. So look at your equation and make sure that it is in the correct format of ax squared plus bx plus c. And that means that all of your values that contain an x and your value without an x are all on the same side of an equal sign, and you have it set equal to 0, which was our first step in solving these anyway. So let's take this and set it equal to 0. And then we're ready to go. And let's identify what is a, what is b, and what is c. And those are essentially just the coefficients that are sitting in front of the variables, the x squared variable, the x variable, and the non-variable term. So my a term is 3, my b term is 1, because when there's nothing sitting here that means it's a 1, and my c is negative 10. And from there, to use the quadratic formula, I simply plug my values in and solve for each x. Notice how this is set equal to x, because x is what is going to be given to me when I finish solving. So x is equal to, and I'm just going to plug into the formula, negative b, so it's negative 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a, which is 3, times c, which is negative 10, all over 2 times 3. Now you need to be careful when you put this into your calculator. You cannot just put it in a big string and expect your calculator to give you the correct answer. You need to follow the correct order of operations prior to putting it into your calculator. So you need to solve for what's underneath of the radical sign first, and then start putting whole things into your calculator. So I like to drill this down a little bit before I start solving this equation here. So I'm going to put square root of 1 minus 4 times 3 is 12 times negative 10 is a negative 120 all over 6. So then we're going to have equals negative 1 plus or minus square root of 1 plus 120 all over 6. And then we're going to have negative 1 plus or minus the square root of 121 over 6. Now here's where I'm going to split it up into two equations. I have two equations because I have both a plus and a minus. So I have negative 1 plus the square root of 121, which is 11, over 6. So I have x equals this value, whatever I get out of here. And I have x equals negative 1 minus 11 over 6. So here I have negative 1 plus 11, which equals 10 over 6, and that simplifies to 5 over 3. So there's my first value of x. That'll be my first x-intercept. And here I'm going to have negative 12 over 6, which simplifies to negative 2. So that is my second intercept. So I should see intercepts when I graph this equation at 5 over 3, 0, and negative 2, 0. So let's take a look at how this would be if I graphed it. I would go to desmos.com and I would plug this in. So let me clean that off of there and go to Desmos. Scoot this over so you can see it. Alright, so let's just plug this in. Let's go 3x squared plus x minus 10. And if I look at these points right here, I see that my x-intercepts, my zeros, are negative 2, 0, and 1.667, which if I converted that to a fraction would be 5 over 3, or if I converted 5 over 3 to a decimal, this is what it would be, comma 0. So you can see that graphing gives you your zeros, and you can check your work very easily by just looking at the graph. So let's take a look at the second example. In this example, we want to find the zeros of g of x equals the square root of 10 minus x squared. And I know my square root symbol looks a little weird there, but that's because I couldn't really draw it on this program. So the first step, and I don't need to apply the quadratic formula to this one because I don't have an equation in the form of a quadratic that can apply the quadratic equation, so I'm just going to have to use basic equation solving techniques on this one. So the first step is always to set it equal to 0. So I have 0 equals the square root of 10 minus x squared. And whenever I want to get things out from underneath of a radical sign, I learned back in algebra, I just square both sides of the equation. So if I'm going to square this, and I'm going to square this, then 0 squared is still 0. And when I square this side, it just comes out of the radical sign. So I'm left with 10 minus x squared. So now I can just simplify this by getting the x by itself. So I'm going to get x by itself in order to solve for x. So I'm going to subtract 10 from both sides because the 10 is positive. And I have negative 10 equals negative x squared. So you need to be really careful of your algebra skills here because you need to pay attention to what your signs are. So I need to divide by negative 1 so that I can have a positive x with which to work. I have 10 equals x squared. So now I need to go back and I need to square root in order to find the value of x. So I'm going to take the square root of both sides, and I'm going to say that x is equal to, and I don't even need to keep going there, I can just say x is equal to positive and negative square root of 10, because I have two values when I take the square root of a number. It can either be the positive or negative side. So let's take a look at what that looks like on a graph. Alright, so let's enter in the square root function in Desmos.com. So if I come in here and I want to enter in a square root function, I need to come down here and get my square root. And I'm going to put this in parentheses so it knows the whole thing is under the radical. And I'm going to put 10 minus x squared. And then I'm going to close my parenthesis. So let's look and see what these roots are. It's negative 3.162 and 3.162. If you take your calculator and take the square root of 10, you will see that it is approximately negative 3.162 and positive 3.162. Those are your positive and negative roots of 10. So let's go on to the last example. In this case, we have a fraction or a rational equation that we need to solve. Let's see how we can get rid of that bottom part of that fraction. That should say f of x equals 2t minus 3 over t minus 5. So we're going to set this one equal to 0, which equals 2t plus, or minus, sorry, 2t minus 3 over t minus 5. Now, if you recall, in order to get rid of a fraction out of an equation, we need to multiply both sides by what's on the bottom so that it will cancel out. If you need review on how to solve these equations, you need to let me know so that I can find you some review sites to help you review these basic equation solving techniques. So on this side, the bottom of my fraction is going to cancel out. On this side, I'm going to get t minus 5 times 0, so it's just going to go away. So that was convenient. Over here I'm left with just 0, and over here I'm just left with the top of the fraction. So that works out all right. So that becomes just a very easy equation to solve. So I am going to then isolate my variable, and I am left with 3 equals 2t, and then last I will divide by 2, and I get t equals 3 over 2. That means I should have one intercept at 3 over 2, 0. So let's just graph that and see what we get. Let's clear this one out, and let's put a fraction in here. So you're going to need to use parentheses to put this in, and you're going to put 2t minus 3, or you're going to use x because Desmos does not recognize t. So 2t minus 3, close your parenthesis, then use your fraction, which is just your divide symbol, and then use a parenthesis again, and t, or x minus 5, sorry, x minus 5, and close your parenthesis. And I don't know what happened there to my minus symbols. Oh, I know, I was using my number pad, and it's not seeing it for some reason. Okay, I think I've got this figured out here. You can use this bar here. Actually, using the division bar worked fine. For some reason my variables or my operations aren't showing up. I'm not sure why. Yours probably will work just fine. Mine just aren't showing up on here. So it's 2x minus 3, and I think it's just Murphy's Law because I'm recording. It happens to me. But anyway, 2x, or x plus 1.5. So let's just see here. So we've got the graph, and this graph doesn't look like the one they show you in the text, and the reason for that is in the text they're not showing you the top portion of this graph because there's no x-intercept on there. There's no root out of the top portion of this graph. And if you look at the bottom portion of the graph, this root is on the y-axis, so we're not interested in that one. This root right here is on the x-axis. We're interested in that one. We're interested in the x intercepts. So that is a root of the equation, and it is 1.5, which is the decimal version of 3/2. If you divide 3 by 2, you get 1.5. So that is how you would find the roots graphically. So don't be fooled if you check your graph and you see more lines than what you thought you were going to see, or you see it intersecting in a couple of points. Like, you know, if you've only got one root and you're thinking, oh, I should only be crossing in one spot. Well, yeah, you're only crossing in one spot on the x-axis, but this is on the y-axis, so you can just ignore that one. You're only crossing in one spot on the x-axis. So that is the last example I have for you, and you can go through and try the checkpoints below each of those examples in your text on page 51. At larsonprecalculus.com you can see the worked solutions for those checkpoints there. So that's 3 more worked solutions that you can see.